Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we are moving on to the next chapter, that is from NCERT class 11th. We'll be bringing you Binomial Theorem, chapter number 8. Today is the turn of exercise 8.1 and one by one we'll be discussing all questions from exercise 8.1. This exercise is a relatively simple exercise because direct formula application of binomial theorem are asked over here. That is, simple expansion is asked in a lot of questions over here. Simple expansion, yes. A few questions based on application of that expansion are also there. We'll be covering all of those questions one by one. Let's discuss this first question as given over here. Expand each of the expressions in exercises 1 to 5. Okay, so we want to expand this 1 minus 2x whole power 5, obviously using the binomial theorem. And how do we do that? For that, let us recall what does the binomial theorem look like. Let us recall what does the binomial theorem look like. Binomial theorem is basically expansion of this a plus b whole power n, where n, we are dealing with n belongs to natural number, positive integers, that's what we are dealing with. N belongs to natural numbers, that is positive integers. This is equal to NC0 a power n b power 0. The first term that begins is NC0 a power n b power 0. B power 0 is obviously 1. The next term, in the next term you have NC1, the power of a will reduce by 1, the power of b will increase by 1. The next term will be NC2, a power n minus 2, b power 2. This is what you have, plus dot dot dot, and the last term that you will have is NCn, a power n minus n, which is a power 0 and b power n. The sum of indices of a and b in all these terms is n, as you can see. The number of terms is n plus 1, as you can see. This is binomial theorem for positive integral index, that's what you can call it. And once you have written this carefully, then what do we do? For 1 minus 2x whole power 5, it is very simple to expand this 1 minus 2x whole power 5. Let's expand this over here. 1 minus 2x whole power 5 will be equal to what? Using this, it can be written as 5c0. The first term 1 will be raised to power 5 minus 2x raised to power 0. This is what you get. This is the first term, right? Okay. The next term will be 5c1 1 power 4 minus 2x power 1. This is what you'll have. The next term will be 5c2 1 power 3. Powers of 1 are gradually reducing and powers of minus 2x are gradually increasing, as you can see over here. This is power 2. In the next term, you'll have 5c3 1 power 2, okay, minus 2x power 3. What about the next term? Continuing further, the next term will be 5c4 1 power 1 minus 2x power 4. The next term, the last term, that will be 5c5 1 power 0 minus 2x power 5. This is what you'll have, right? What next? We'll have to simplify all of these terms next. Let's simplify all of these terms next. What do we have? 5c0, the value of 5c0 is simply 1. 5c0 is simply 1. 1 power 5 is also 1. This is minus 2x power 0, which is also 1. So this is simple term. This is 1 only. Okay. Since this is 1 only, therefore this is particular. This is 1. Right. What next? 5c1 is 5. 1 power 4 is 1. This is minus 2x. What is that? Minus 2 times x. 5 times minus 2 will be minus 10. This becomes minus 10x over here. Okay. What about this 5c2? If you recall the value of 5c2, or you can find the value of 5c2 as 5 factorial by 2 factorial 3 factorial, or in other words 5 into 4 upon 2 into 1. What is that? 5 into 4 upon 2 into 1 would be 20 by 2, which is 10. So this is plus 10 times 1 power 3 is 1 minus 2x power 2. This is 4x square. This becomes 4x square. Okay. Next terms. What is 5c3? 5c3 is same as 5c2, and 5c2 was obviously 10 over here. This is 10 times 1 square, which is 1, minus 2x power 3. Next thing is minus 2x power 3. What is that? This is minus 8 x power 3. This will become minus 8 x power 3. 2 power 3 is this, right? 5c4 is simply 5. 1 power 1 is 1 only. What is minus 2 power 4? Minus 2 power 4 will be 16. And this will be 16 times x power 4. What next? 5c5 is 1. This is again 1. 1 into 1 is 1. What is this? Minus 2 power 5, which is minus 32. This becomes minus 32 x power 5, as you can see over here. The last step which remains is to multiply the remaining things, and this is 1 minus 10x, which is okay. This is 40x square, and this is minus 80 x power 3, that is 80 x power 4, and this is minus 32 x power 5. This is the final expansion, and yes, that should be my final answer. That is my final answer of expansion for this question over here. Is that all? Yes, that's all in this question. Let's discuss this next question that we have in front of us. Expand. We are supposed to expand this 2 by x minus x by 2 whole power 5 using binomial theorem as well. How do we do that? Let's take a look at this expansion. So 2 by x minus x by 2 whole power 5 can be expanded using binomial theorem as this is. The first term will be 5c0. First is 2 by x power 5 is what you'll have. The next term, that is minus x by 2, will be power 0. Okay. Plus after that 5c0. After 5c0 you'll have a 5c1. This 2 by x power 4 and minus x by 2 power 1. This is the next term. What about the next term after this? That will be 5c2 2 by x power 3 minus x by 2 power 2. This is what you'll have. Write down the next term after this. This is 5c3 2 by x power 2. Okay. And minus x by 2 power 3. You may observe that the powers of 2 by x, that's the first term, are continuously decreasing by 1 units. Okay. 5c0, 5c1, 5c2, 5c3 and 5c4, 5c5 will be the terms. And minus x by 2, the power of minus x by 2 is increasing by 1 units gradually, as you may observe. The next term will be 5c4 2 by x power 1 minus x by 2 power 4. The last term will be 5c5 minus x by 2 power 5. Since 2 by x power 0 is simply 1, I've skipped that, right? That's simply 1. This is the complete expansion, and what will this value be further equal to? This is 5c0 2 by x power 5. What will this simplify to? 5c0 is 1, 2 by x 2 power 5 is 32, x power 5 is this, and this is simply 1. What about the next term over here? 5c1 is 5, let's write it as this. 2 by x power 4 is 2 power 4, which is 16 upon x power 4 times this minus x by 2 power 1 is same, minus x by 2 plus, let's focus on the next term, 5c2. Now 5c2 is actually 5 times 4 over 2 times 1. What is this? 2 by x whole power 3, which is 2 power 3, 8 over x power 3. What is minus x whole square? That is x square. What is 2 square? That is 4. What is 2 square? That is 4. Okay, what about this term 5c3? 5c3 is same as 5c2, which is 5 times 4 over 2 times 1, and 2 by x whole square. What is that? In the numerator you have 2 square, which is 4. In the denominator you have x square. What about minus x by 2 whole power 3? You have minus x power 3 in the numerator, which is minus of x power 3. In the denominator you have 2 power 3, which is 8. That's what you have, right? What about the next term? 5c4. 5c4 is simply 5. And then you have a 2 by x in the product. Then you have minus x power 4 upon 2 power 4. Minus x power 4 will be x power 4 simply over 2 power 4 is 16. 5c5 is 1. What about minus x power 5? That is, there will be a minus remaining since it is odd power. So this will be minus x power 5 whole divided by 2 power 5, which is 32. This is what you get. This is what you get. Okay. Next, let's focus on simplifying this. This will be equal to 32 upon x power 5. Okay. What is this term? You have a minus over here extra. So minus will come out and what you'll get is, please observe, this is 16 by 2 which is 8. 8 times 5 is 40. So this is minus 40 and in the denominator you will have x power 3. Can you observe that? Yes. X upon x power 4 is 1 upon x power 3. Next, what do you have over here is 4 times 2 is 8. This will get cancelled and in the numerator you have 5 times 4 which is 20. Okay, what about power of x? In the numerator you have x square, denominator you have x cube. X square will get cancelled and in the denominator one x will remain extra. So this is 20 times 20 upon x. This is what you have, right? What next? Let's focus on this term over here. So you have 2 into 8 in the denominator which is 16. 4 into 4 is also 16. They will get cancelled. You have a minus which is extra. Minus 5 is the coefficient of x cube upon x square, that is x. So this is minus 5x. Is that okay? Yes. Next term, let's focus on this term over here. This is 2, this is 16, this will be 1 upon 8. There's a 5 over here in the denominator you have 8. So this is plus 5 upon 8 and x power 4 upon x is actually x power 3. That's what you get, right? What about the last term? This is minus, minus is extra, minus x power 5 upon 32. This is minus 1 by 32 times x power 5. This is what you have. So that expansion of that expression is this. Yes, this is the final answer for this question as you can see clearly. Let me get a side so that you can take a look at the complete solution and that's all in this question. Let's talk about this expansion next. 2x minus 3 whole power 6. This time the power given is 6 and there is a term 2x minus 3. How do we go about solving this one? Let's take a look at the solution. So 2x minus 3 whole power 6 can be expanded by taking first term as 2x, second term is minus 3. Power 6 would imply that you start with, your term start with 6c 0. First term that is 2x power 6, second term power 0. Second term power 0 is simply 1. This is 2x power 6. Next term 6c 1, that's the next term. First term that is 2x power, first term of the binomial 2x power 5 and the second term of the binomial minus 3 power 1 is what you get in this term. Okay. Then you have 6c2, okay, 2x power 4 minus 3 power 2. Observe carefully that the power of 2x has reduced by 1, power of minus 3 is increased by 1 in 6c2. After that you will have 6c3, okay, let's write 6c3. Now what is that? What will that have? 2x power 3 minus 3 power 3, this will be there in 6c3. Next, plus 6c4, then you have 2x power 2 minus 3 power 4. This is what you get. Next term 6c5, 2x power 1 minus 3 power 5. What about the last term? That is 6c6 times minus 3 power 6. This is what you have in the last term, right? Take a look at this carefully. Then simplify this, simplify each of these terms. How do we do that? So for that I need the value of 6c0. Now nc0 is always 1, so 6c0 is 1. This is 2x whole power 6. This will be 2 power 6 times x power 6. Now what is 2 power 6 equal to? 2 power 6 is 64. This is 64 x power 6 plus the next term 6c1. nc1 is n, so 6c1 is 6 times 2x power 5, that is 2 power 5 times x power 5. What is 2 power 5? This is 32 x power 5. This is minus 3 over here. That's in the product once again. What else? Plus 6c2. Now what is 6c2 equal to? Focus. 6c2 is 6 times 5 upon 2 times 1. Yes? Let's write it as that. What is 2x power 4? 2x power 4 is 2 power 4 times x power 4. And 2 power 4 is further 16. So this is 16 x power 4. What is minus 3 square? Minus 3 square will be actually plus 9. So this is 9 plus. What is 6c3 equal to? 6c3 is 654 upon 321. Right? 654 in the numerator over 321 in the denominator. That's what you have, right? 2x power 3 will be 2 power 3, 8x power 3, which is 8x power 3. What is minus 3 power 3? There will be, since it is odd power, there will be a minus there remaining, and 3 power 3 is simply 27. So this is minus 27 7. What about 64? The term of 64, this term over here. 64 is similar to 62. 64 is same as 62. So this will be 6 times 5 over 2 times 1. What is 2x whole square? 2x whole square will be 2 square times x square. 2 square is 4 and x square. This is what you have, right? What else? Minus 3 whole power 4. This will be positive 3 power 4. 3 power 4 is 81. So this will be 81 multiplied over here. What is 65? 65 is simply 6. Okay. And 2x power 1 will be simply 2x. Minus 3 power 5. Now that is interesting. This will be minus of 3 power 5. Since the power is odd, there will be a minus remaining. So this is minus of 3 power 5. Now what is 3 power 5 equal to? 3 power 5 is simply 243. So this is minus of 243 in the product over here. What else? The last term. Let me write the last term over here. 66 is 1 and minus 3 power 6. What is that? This is minus power 6 will be positive and 3 power 6 is same as 9 cube or whatever you want to call it, 27 square, that is 729. This is 729, right? So what all have I used over here? Let me just write them again, that I have used a few things over here. I have written 6c2 as 6 factorial over 2 factorial 4 factorial, which actually simplifies to 6 into 5 over 2 factorial, which is 2 into 1. I have used this, one of these things. Then I have also used 6c3 is equal to 6 factorial by 3 factorial 3 factorial. This simplifies to 6, 5, 4 times 3 factorial, and 3 factorial will get cancelled. Another 3 factorial which will remain here is this. So I have used 6c3. I have written 6c3 as this. Is that it? Okay? Yes. I have also used the powers of 3. Now what powers of 3 have I used over here? 3 power 3. 3 power 2 you are aware of. 3 power 2 is 9. 3 power 3 is 27. 3 power 4 will be 27 times 3, which is 81. 3 power 5 will be 81 times 3, which is, and 3 power 6 will be 243 times 3, which is 729. 729 is also 9 cube. It is also equal to 27 square. It is also equal to 27 square. Right. So this is something that I have used over here. Yes. Should we also remember these things? Yes. These 3 powers. Yes, you should remember. You should be aware of these things beforehand. Right. Okay. So what next? This simplifies to, this is 1 times 64, which is simply 64 x power 6. What is this? This is 6 times minus 3. There will be a minus first of all. Okay. This 6 times 3, which is 18. 18 times 32 is what we are supposed to find over here. Or for that matter, you can multiply this 3 by this 32 by this 3. This is 96 times 6 is what we are interested in. And how do we find that? Let's take a look at this. This is 32 times, let's multiply 32 and 18. Seems easier. 32 and 18. Okay. What does that give me? 8 times 2 is 16. 6, 1 carry, 8, 3, 24, 25, 26, 27. 2 carry, 3, 1, 3, 5. This is what I get, 576. 32 times 18 is 576. So you get a minus 576 x power 5. This here is my rough work, right? Okay, 576 x power 5. What about this? Let's simplify this somehow. And I have a 2 over here. This gets cancelled with this. There will be 8 at the top. And we have 9 times 8. 9 times 8 is 72. And this is 3 times 2 times 5. 2 times 5 is 10. Let's not worry about that. 72 times 3 is what we are interested in. Okay. 72 times 3, that is 216, right? 216. So this is 2160 plus 2160 x power 4. That is what you get over here. 2160 x power 4. That's what you get over here. What about the next one? There's a minus remaining over there. Yes. The first thing we observe is this minus. Then we observe that some terms get cancelled. 3 times 2 is 6. This will get cancelled. And what else remains is this. You have 5 times 4 times 2 times 27. Okay. Now 5 times 2 is 10. Let's not worry about that 2. Another 2 remains in this 4. 2 times 8 is 16. And 16 times 27 is what we are interested in. Okay. 16 times 27. 16 is 2 power 4. 27 is 3 power 3. Now what will they multiply to? They will be equal to actually 6 power 3 times 2. 6 power 3 is 216 times 2 is 432 and 4320 is what you'll get. 4320. This is x power 3. 4320 x power 3. Yes. Can we also confirm that? Confirm that? Yes, maybe. This is 8 and 27. 8 and 27 is 2 power 3, 3 power 3, which is actually 6 power 3. 6 power 3 is 216. 216 times 2. 2 from here would be equal to 432. 432 times 10 is 4320. Right. That's okay. What else? What else? Let's move on further. And next we talk about this. 2 times 2 is 4. So, in this question, what do you have? In this part, in this term, what you have is this 5 times 2, which is 10. 6 times 81. Let's multiply them together. Okay, right. So, there's a 3 hidden over there. 3 will go to 81 and it will become 243. Okay. There's a 2 remaining over there. 243 times 2 will be 486. Right. And there's a 10. So, this will be 4860. Right. And what's the power of x that will you have? X power 2 is what you'll have over there. What about the next one? There's nothing in the denominator. That's okay. So, only the numerators will be found. There's a minus over there. So, let's write a minus first of all. This 6, there's a 3 hidden over there. 3 times 2 times 2 and this is 243. Okay. So, one thing is we multiply these two together and we'll multiply this by 12. Another idea is that it is easy to double and all. So, there's a 3 hidden over there. Let's guess this 3 to 243. It becomes 729, right? 729 times 2 is what we are supposed to find. 729 times 2 is 1458. 1458 times 2 will be 2916. 2916. So 1458, 28, 29 and 16. This will be 2916. 2916 and this will be x plus 729. Is it all? Yes. This is the final expansion and yes, that is my answer for this question. Let me get aside for you to take a look at this. That's all for this question. Let's discuss this question in front of us. The question says expand this expression x by 3 plus 1 by x whole power 5. Now how do we go about solving this one? We'll obviously use the binomial theorem. We know the expansion of binomial theorem and so it will be pretty easy to handle this question. Let's see, this is power 5. So this expansion will be equal to 5c0 first of all, right? The first term is x by 3 power 5. The next term 1 by x power 0 will be simply 1. Let's not worry about that. The next term of this series will be 5c1 times the first term of the binomial is x by 3. X by 3 will be raised to power 4. The power will reduce and 1 by x. For 1 by x the power will increase by 1, right? This is what you get. Plus next term will be 5c2 x by 3 power 3. Times 1 by x power 2. Yes. For the next term, you can observe that the power of x by 3 is reducing by 1 units and the power of 1 by x is increasing by 1 units. So the next term will be 5c3 x by 3 power 2 and 1 by x power 3. This is what we'll get. What about the next term? Next term will be 5c4 times x by 3 power 1, 1 by x power 4. Plus next will be 5c5 x by 3 power 0, which is simply 1 and 1 by x power 5. This is the expansion that you have. Okay. Once you have written this expansion clearly, next what you can do is we can simplify this, right? What is 5c0? 5c0 is simply 1. What is x by 3 whole power 5? Now for that we should be aware of what is 3 power 5. Let's find 3 power 5. 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, 3 power 4 is 81, 3 power 5 is 243. Yes. So this is x power 5 over 243 plus this is a 5. 5c1 is simply 5, right? What about x by 3 power 4? So for that, numerator will be x power 4, but the denominator would be 3 power 4. Now 3 power 4 is equal to what? 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, 3 power 4 is 81. What about this? This is 1 over x plus What is 5C2 equal to? Now 5C2 is 5 times 4 upon 2 times 1. This is what we have, right? What about x by 3 power 3? This will be x power 3 over 3 power 3. Now what is 3 power 3? 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27. Okay. What is this? This is 1 by x square. 1 square is simply 1, right? No need to worry about that. Now what is 5C3 equal to? Now 5C3 is same as 5C2. Since NCR is same as NCN minus R, right? So this is 5C2. 5C2 will be 5 times 4 upon 2 times 1. What next? X by 3 whole square. This will be x square in the numerator upon 3 square, which is simply 9 in the denominator. The next term would be 1 by x power 3 over here. Yes, this is what you get. What next? 5C4 will be simply 5C1, which is 5. X by 3 remains as it is, and here you get 1 upon x power 4. Is that okay? Yes. The next term will be 5C5, which is 1, and this is 1 upon x power 5. This is what you get. That's the series in front of us. After this, when we see the powers of x, this is x power 5, this is x power 3, this is x power 1, this is x power minus 1, 1 by x actually, this is 1 by x cube, 1 by x power 5. You see they are all different terms, there are no like terms over here, so we don't need to worry about adding anything. Let's simplify this further, and this is x power 5 over 243 plus, what is this equal to? You may observe 5 upon 81 is the coefficient. That cannot be simplified further, and this is x power 3 plus, what is this? Observe carefully, this is 5 times 4, which is 20 by 2 is 10, 10 by 27. Is there anything else cancelled out? No. 10 by 27, nothing gets cancelled, and this is x plus, what is this? 5 times 4 is 20 by 2 is 10, 10 upon 9 is what I have over here, 10 over 9, and what remains is, as you may observe, this is 1 over x plus, what is this? This is 5 upon 3 is the coefficient, and x upon x power 4 is 1 over x power 3. What next? The next term is 1, which is okay. This is 1 over x power 5, and yes, this is the required answer for this series expansion, as you can clearly see over here. Is that all? Yes, that's all in this question. Let's discuss this next question on the board over here. Expand. We have to expand this x plus 1 by x power 6. Okay, so in this case we have power 6, but as you may observe, the coefficients will be pretty simple, because you just have 60, 61 and 62. There are no numbers involved in this, right? You just have to worry about the powers of x, that's all, right? Let's take a look at the expansion. We have the first term will be 6C0. In the binomial, the first term is x, the second term is 1 by x. So we'll begin with x power 6 and 1 by x power 0. 1 by x power 0 is 1, right? So we just write x power 6. Next term. For the next term, you'll have a 6C1 as the binomial coefficient, and the power of x will reduce by 1. You'll have x power 5. The power of 1 by x will increase by 1. You'll have 1 by x power 1 plus. The next term will be, as you may observe carefully, this is 6C2. This is x power 4. The power of x reduces. The power of 1 by x increases. Therefore, you have 1 by x power 2. Next, after 62, we have 6C3. X power 3. The x power of x reduces. The power of 1 by x increases to 3. Yes. In the next term, you'll have 6C4 as the binomial coefficient. X power 3 will become x power 2 now. 1 by x power 3 will become 1 by x power 4 now. Plus, in the next term, you'll have binomial coefficient as 6C5. Next, x power 1, 1 by x power 5 plus. What next? In the next term, you'll have binomial coefficient 66. The power of x will be 0, which is 1. The power of 1 by x will be 6, yes. So this is 66. X power 0 is 1. You'll have 1 by x power 6. This is what you have. Is that okay? Yes, pretty simple. What is the value of 6C0? NC0, as you may recall, NC0 is always 1. So 6C0 is simply 1 times x power 6. Okay. What is 6C1? 6C1, you may recall, NC1 is simply n. Okay. So 6C1 is simply 6. So you have 6 x power 5 upon x, which is x power 4, plus what is 6c2? Let's find 6c2 over here in the rough. Okay. Let's find 6c2 over here. What is the value of 6c2? 6c2 will be 6 into 5 over 2 into 1. What is that? That's simply 15, right? That's 15. So you'll have 15 times this x power 4 upon x square. What's that? Simply x square. Plus, what is 6c3 equal to? Let's find 6c3 as well. 6c3 is 6 into 5 into 4 over 3, 2, 1. What is that? This is 20. This is 20. Once you observe this carefully, then you can write the next term as 20 times. What is the power of x that you'll observe over here? You have x power 3 upon x power 3, which is simply x power 0. That's 1. Plus, this is 6c4. 6c4 is same as 6c2, which is 15. Okay. What do you get over here is x square in the denominator. X square upon x power 4 will be in the denominator, you get x square. Plus 6c5 is same as 6c1, which will be 6. And here you have x upon x power 5 will be 1 upon x power 4. Plus the last term, 66 is 1. And you have x power 6 in the denominator. This is my final answer for this question. Is that it? This is it, right? That is what you get at the end. That's the complete expansion of this series. Let's discuss this next question in front of us. We are asked a very interesting thing here. Using binomial theorem, we have to evaluate this 96 power 3. Okay, and how do we go about doing this? So, can we write this 96 as sum or difference of two terms whose powers are easy to find? Yes, that's what we can do. That's something that we can do very easily. We can write 96 as 96 can be written as 100 minus 4. Now powers of this and powers of this are something which we can handle very easily, right? So let's write 96 power 3 as 100 minus 4 power 3. And now this is a binomial, right? This is a binomial. Power 3 will expand using binomial theorem, or obviously this is simply a minus b power 3. You already know the result of that, right? This is a cube minus 3a square b plus 3ab square minus b cube, right? That's something which you can use directly. That is also derived from binomial theorem only, right? Binomial theorem is an extension of all of these things. So this is, let's write in terms of a cube, but before that, let's use 3c0, right? Let's use binomial properly. This is 3c0, 100 power 3 minus, where did you get this minus from? Let's not get that minus. This is 3c1, 100 power 2. The power of 100 reduces. The power of minus 4 was 0 over here. The power of minus 4 will increase over here. This will be minus 4 power 1 plus 3c2, 100 power 1. The power of 100 is reducing. The power of minus 4 will increase. Plus 3c3, the power of 100 will be 0. The power of minus 4 will be 3. This is what you get. Okay. Next, let's move on to the next step. This is 3c0, which is 1. This is 100 power 3, which is 1 followed by 6 zeros. Yes. This is 3, which is okay. This is 100 square, which is 1 followed by 4 zeros. And you have a minus 4 in the product. Plus 3c2 is again 3 times 100 times minus 4 square, which is 16. Yes. What is 3c3? This is 1. And what is minus 4 cube? This is minus 64. That's what you have. Simplified further. 1 times this is same. 1, 2, 3, 4, 5, 6 zeros. You have minus 12 times 12 and you have 4 zeros accompanying it. Then you have 3 times 16. What's 3 times 16? 48, and you have 4800. What next? You have minus 64. Let's add up the terms having plus sign and let's add up the terms having minus sign together. Let's bring them together, and what you get over here is this is 0048, 0048. So you'll have 1004800 over here when you add this and that. That's pretty simple. What next? You add these two after taking a minus common, and what you get is 120064 is what I get. Is that okay? Yes. Once you're through with this much, what next? We just have to subtract these two. Let's subtract 10 minus 4. You'll carry on a 1, and what you're actually doing is you are subtracting 064 from this 800 actually, and what's that? In the end you have 736. Is that okay? Yes, that's pretty simple. What about the next terms? 120 has to be subtracted from this 004. Is it? Yeah. So is it possible to subtract 120 from 004? No, we'll have to carry on something, right? So we are actually subtracting 120 from 1004. 120 from 1004, and 1000 minus 120 is 880. 880 plus 4 is 884. This is what you get. This is what you get. So that's the complete subtraction. Yes, you get a 4, then you get a 8, and then you get a 8 again. Is it? Yes, that's what you get. Next, we can move on to the next one, but before, this is the final answer for this question over here. Let's discuss this question next. Using binomial theorem, we have to evaluate this 102 power 5. 102 power 5. How do we do that? Okay, so for 102 power 5, we'll have to write 102 as sum of 102. Okay, two numbers whose powers are easy to find. Let's write 102 as 100 plus 2 whole power 5. Okay. Once you write it as this, what next? This becomes 5C0. We can expand using binomial theorem. The first term will be having binomial coefficient 5C0, 100 power 5. This is what you have in the first term. The next term will be 5C1 binomial coefficient, 100 power will be 4. The power of 100 will reduce by 1. The power of 2 will increase by 1. What about the next term? Then you'll have 5C2 as the binomial coefficient, 100 power 3 and 2 power 2 is what you'll have. Right? The power of 100 is reducing by 1. The power of 2 is increasing by 1. The next term will be 5C3 times 100 power 2, 2 power 3. Power of 100 reduces, power of 2 increases. Next we'll have 5C4, 100, 2 power 4 plus 5C5 times 100 power 0, which is 1, and 2 power 5 is what you'll have over here. What next? This 100 power 5 is actually 1 followed by how many zeros? 10 zeros. This is actually 10 power 10. 5C0 is simply 1. We are not supposed to worry about that too much. And what else? This is 5 times 10 power 8 times 2. Let's write in terms of power. So like write the expanded form as well after multiplying all of this together, plus 5C2. 5C2 is 5 times 4 upon 2 times 1. By now you would have maybe remembered this value as well. 5C2 is 10 only. 100 power 3 is 10 power 6. This is 2 power 2, which is 4. Plus 5C3 is same as 5C2, which is 5 times 4 upon 2 times 1 into 100 square is 10 power 4. Plus 2 power 3 is, this is multiplied by this. So this is 8 plus 5C4. What is 5C4? 5C4 is simply 5. Okay, you have 100 over here, and you have 2 power 4, which is 16 over here, plus 2 power 5 is simply 32. That's what you have, right? Take a look at this complete series. Next, let's write each and every term properly. This is 1 followed by 10 zeros. 6, 7, 8 zeros. No, this is followed by 10 zeros actually. So there are 2 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, a big number. 5 times 2 is 10. 10 into 10 power 8 is 10 power 9. So this is basically 1 followed by 9 zeros. This is what you have. Plus, what next? So this is 5 times 4, which is 20, by 2 is 10. This becomes 10 power 7. Okay, and there's a 4, so 4 will be followed by 7 zeros. This is what you get. Next, what you have over here is, this is again 10. 10 times 10 power 4 is 10 power 5. We have a 8, so 8 will be followed by 5 zeros. Plus, what you have is 16 times 5 is 80. 80 is followed by 2 zeros. So you get 8000 plus you get a 35. So this is 2 power 5, which is 32 actually, not 35. This is 32, right? This is 2 power 5, which is 32, right? Let's write this properly. And once we are through with this 32 will get added over here, added out over here, rest all are 0. So if you begin from the right hand side, what you get is 3, 2 over here. The last 2 digits will be 3, 2. Okay. What about the last 3 digits? If you observe, there's a 80 over here, there's a 0, 0 over here, there are 0 zeros over here. So the next 2 digits that you'll have is 8, 0. Right? We've added these terms. Yes. What next? This is 8, 0. Okay. So 2, 2, 2. You'll have 8, 0 over here. Again, you'll have 8, 0 over here. Is that okay? Yes. So what you have done is you have added the last 6 digits. Okay. It's time to move on to the next one. And this has been taken care of. This has been taken care of. This has been taken care of. This here will have 4, 0. Okay. Before that. And what do we have? 2, 2, 2. 2, 2, 2, and this is 0, 0, okay, 2, 2, 2, and this is again 0, 0. So 0, 0, 0, 0 and 4, 0 added together will be actually 4, 0 before this. What about one step before this? Okay, so for that we are adding this 10 and this 100. This is 1, 1, 0. So the final answer becomes 1, 1, 0, 4, 0, 8, 0, 8, 0, 3, 2. That's the final answer for this question over here, as you can see behind me here. Let's try to solve the next one over here. Using binomial theorem, we have to expand 101 power 4. Now, how do we go about doing that? We have to write 101 as 100 plus 1 whole power 4. 100 plus 1 whole power 4. This is what you are supposed to do. Okay, this becomes 4C0. This becomes 4C0 times 100 power 4. Okay, 1 power 0 is same as 1. Plus, the next term will have binomial coefficient 4C1. The power of 100 will reduce by 1. And the power of 1, the second term in the binomial expansion, will be increased by 1. But 1 power 1 is also 1, right? Let's write 1 power 1. Plus, 4C2 is times 100 power 2. 1 power 2 is what I get. Plus, the next term, 4C3. We'll have 100 power 1 times 1 power 3. 4C4, for 4C4 you'll have 100 power 0 and 1 power 4. It's pretty simple, right? Not at all difficult. What is this? This is 4C0, which is 1, and 100 power 4, which is 1 followed by 8 zeros. 100 power 4 is 1 followed by 8 zeros over here, right? Plus, what you have over here is 4C1 times 100 power 3. 100 power 3 will be actually 6 zeros. This is 4. 4 times 6 zeros actually this. 6 zeros. This is what you get. What about 4C2? 4C2 is 4 times 3 by 2 times 1, which is 6. 6 followed by 4 zeros. Plus, what do you have? 4C3 is 4 followed by this, and this here is 4C4, which is 1. Right. And let's add them together. Let's add them together. What do we have? Okay. Let's mark proper commas this time around. So you can add the last 3 digits very easily. Last 3 digits can be added very easily. After that, what we can do is, let's take 3 more digits. Let's take 3 more digits and we can add them together as well, right? Let's begin with the last 3 digits. What do you get? In the last 3 digits is 000, 000, 000, and this is 401. In the last 3 digits, you have 401. Before that, in the next 3 digits, from back, this is 000, this is 000, this is 60, and there's nothing over here. This is 060, the next 3 digits. What about after that? You have a 4 and you have a 100. So this becomes 104. So the final answer that you'll get is this. The final answer that you get is this. 104060401. That's the final answer for this question. Let's discuss this question next. 99 power 5 has to be found using binomial theorem. Now how do we go about doing that? We'll have to write 99 as 100 minus 1 power 5. Okay. and this will have an alternate plus minus sign. Yes, alternate plus minus sign will be there. The second term in that binomial is minus 1, or you can say if you are using alternate plus minus sign, you can take 1 as well, right? So this is 5C0 times 100 power 5 minus 5C1 times 100 power 4 plus alternate plus minus sign, yeah? This would be minus 1 power 1, which is simply minus, right? Then you have 5C2 times 100 power 3. Minus 1 square will be plus 1, right? This is, next term will be minus actually. So what you get is this becomes 5C3 100 power 2 plus alternate plus minus, right? Next term will be 5C4 times 100 power 1 and 5C5 times this. Right, that's what you get. Is there anything else? No. Next, what is 100 power 5? 100 power 5 is actually 1 followed by 10 zeros. 5C0 is 1 only, so this is 1 followed by 10 zeros. Those are 10 zeros, right? Let's separate them out by commas, and this is what you have, right? This is what you have. What next? This is 5C1. 5C1 is 5 followed by 100 power 4, which is 8 zeros. 5 followed by 8 zeros. Okay, let's separate them out by commas. This is what you have. 5C2. 5C2 is 10. 10 into 100 power 3, which is 6 zeros. 10 into 6 zeros. So 10 will be followed by 6 zeros. 10 will be followed by 3 plus 3, 6 zeros, right? This is what you get. What next? You have 5C3 times 100 square, which is minus 5C3 is again 10 followed by 100 square, which is 4 zeros. Let's separate by comma. 5C4 is 5 followed by 2 zeros minus 5C5 is 1. This is what you have. Now, what next? How do we go about solving this further? So for that, we can focus on, first of all, adding all the terms having plus sign, subtracting all the terms having minus sign, grouping them together, and then we can make one further calculation. Another idea could be to subtract these two first of all. Subtract these two first of all, and you'll get 3 terms in plus. You can add those terms very easily. Let's use this idea over here. What do we have? Here you have 3 zeros, and then a 500, 3 zeros, then a 500 over here. So you'll actually have these 7 zeros will remain as it is. Okay, 3, 3, 6, 7, 8 zeros will remain as it is from the back. 0, 0, 0, 0, 0, 0, 0, 0. And from this 100, you have to subtract a 5. That's what you're supposed to do. From this 100, you have to subtract a 5. That will be 95 actually. This becomes 95. This, and this. This becomes 95. Yes? Is that okay? Yes. What next? Let's subtract this from this. Okay. So this is 0, 0, 0. This okay. This is 100, which will be subtracted from this 000. Okay. So what you'll have is at the end there will be 5 zeros. We don't have to worry about the 5 zeros at the end. 5 zeros at the end. Okay. And you have a 5,000 remaining. 5,000 remaining. Okay. Sorry, just a minute. This is not 5,000. We have focus on this one, right? You have 5 zeros at the end, 5 zeros at the end. You have 100 remaining. 100 minus 1. 100 minus 1 is 99 actually. This is what you have, right? This is what you'll have. Is that okay? Yes. What is 500 minus 1? 500 minus 1 is 499. Take care of the calculations very carefully. What next? Let's take a look at this one next. At the end you have 000, 000 and 499. So add them together and you will get 499 at the end. What else? The next group has 900 and 000 over here. You'll get a 900 on adding them together. After that you have a 9 and you have a 500. Add them together. You will get 509. And there's a 9 remaining. So this is 9509 900 499, and that is the answer for this question over here. As you can see behind me, the complete calculations are done over here. Let's discuss this question next. The question says, using binomial theorem, indicate which number is larger. Okay, so you have a 1.1 raised to about 10,000 or 1000. Which number is larger? Let's take a look at this one. Now, how do we use binomial theorem for this? This expression is pretty simple, but this expression is complicated. Can I write it in the form of a binomial power, something nice? This can be written as 1 plus 0.1 raised to power 10,000. This is what you have. What can I write it as? This can be further written as 10,000 C0, 1 power 10,000, which is 1, 0.1 power 0, which is 1. So this is what you get. Plus, you will have 10,000 C1, 1 power 10,000 minus 1, which is 1 only. But 0.1 power 1 will also come over here. This. Next term, what you'll get is 10,000 C2 into 0.1 power 2. Plus dot dot dot. A few more terms will come. But you observe, this term will be positive, this term will be positive, all other terms will be positive. There will be a lot of terms, but all of those will be positive terms, although the magnitude will gradually reduce. But what about this term? This is 1, 10,000 C0 is simply 1. 10,000 C1 is 10,000 times 0.1 is what you have. Plus, you have some more positive terms. This is what you have. You have some more positive terms. This is 1. Plus, what is this? This is 10,000 into 0.1 is actually 1,000. Plus some positive terms. Yes, yes. Now, can you observe that 1 plus 1,000 plus some positive terms, or 1,000 plus some positive terms is actually greater than 1,000? Yes or no? Yes. And yes, we wanted to compare this along with this 1,000. Yes, what do we observe? That this expression is equal to this expression, which is greater than 1,000. So, which number is greater? Therefore, we can conclude that 1.1 power 10,000 is greater. That's what you can guess from here easily. That's all? Yes, that's all in this question. Let's discuss this question next. The question says find a plus b whole power 4 minus a minus b whole power 4, hence evaluate this expression. Okay. How do we go about solving this? For a plus b power 4, what we can do is we can simply use binomial expansion. For a minus b power 4 as well, we can use binomial expansion. So let's write a plus b whole power 4 first of all. What is this equal to? The first term will be 4c0 a power 4. b power 0 is simply 1. The next term will be 4c1 a power 3 b power 1. Then you will have 4c2. The power of a will reduce, the power of b will increase. This will be a square b square. 4c3 a power 1 b power 3 and 4c4 b power 4 is what you have. Is what you have. Right. If you replace b by minus b, you will get a minus b whole power 4. And what happens in this case is alternate terms become minus. This will be minus, this will be plus, this will be minus, this will be plus. So you'll get 4c0 a power 4 minus 4c1 a power 3 b. The next term will be plus. The same term will come over. 4c2 a square b square. The next term will be minus. What you get is 4c3 a b power 3. The next term will be, this term would be minus actually. Let's write a minus over there. This term will be minus. The next term will be plus. And this is 4c4 b power 4. You see a b cube over here, right? Second term minus b power 3 will remain, will give us a minus extra, right? That's what you get. But are we interested in this? No, we are interested in something beyond this. That is, we have to subtract these terms. We have to subtract these terms. And on subtracting in the LHS, what you get is a plus b whole power 4 minus a minus b whole power 4. Therefore, this is equal to what? These terms get cancelled. 4c1 minus or minus 4c1 will get added. You'll get 2 times 4c1 a power 3b. What else? These two will get cancelled. This will again get added and you'll get 2 times plus 2 times 4c3, 2 times 4c3 a b power 3. These will also get cancelled and this is the simplified version of this. Okay. Can we simplify it further? Yes, we can simplify it further. What we'll have is 4c1 and 4c3 are same, they are equal to 4. So let's take a 4 common. 2 times 4 is 8. Okay. You have a cube b, you have a b cube. You can take out a common. Yes, you can take out a b common as well. You can take out 8ab. What remains is a square plus b square inside this. That's the simplified version of this. 8ab a square plus b square. Is that okay? Yes. Hence, you have to evaluate something else. Hence, on the basis of this, you have to evaluate something else. So, for evaluating that, you observe that a has been replaced by root 3, b has been replaced by square root of 2, a has been replaced by square root of 3 and b has been replaced by square root of 2. So, let a equals square root of 3 and b equals square root of 2. If you take this and this, then what do you observe? This becomes root 3 plus square root of 2 power 4 minus, this becomes square root of 3 minus square root of 2 power 4 is equal to what? This minus this equals 8 times square root of a. A becomes the square root of 3, b becomes the square root of 2 and this becomes square root of 3 whole square which is 3. This becomes square root of 2 whole square which is 2. This is 5. 5 times 8 is 40. Root 3 times root 2 is root 6. That is my answer over here. That is my answer over here. 40 root 6 is the answer for the second part in this question. And that's the complete solution of this question. Let's discuss this question next. Find x plus 1 whole power 6 plus x minus 1 whole power 6. Hence or otherwise evaluate this root 2 plus 1 whole power 6 plus root 2 minus 1 whole power 6. How do we go about doing that? Let's try to solve x plus 1 power 6 first. What is this? This is x plus 1 power 6. Power 6 is equal to what? This here will be equal to, as you may observe, 6c0 x power 6. 1 power 0 which is 1. The next term, binomial coefficient will be 6c1. The power of x will reduce, the power of 1 will increase, but will that impact anything? No. 1 power, 1 will be 1 only. The next term will be 6c2, x power will reduce to 4, 1 square will be simply 1. The next term will be 6c3, x power 3, 1 power 3 which is 1 only, plus 6c4, x power 2 times 1 power 4 which is 1, 6c5 times x times 1 power 5 which is 1 again, 6c6 times x power 0 times 1 power 6 which is 1. So this is what you get, x plus 1 power 6. What about the next one, x minus 1 power 6? Now this term had a 1 power 1. Next term will have a minus 1 power 1, there will be a minus over here. So every alternate term will have a minus. You can observe every alternate term will have a minus. The first term will be plus. Terms will be exactly same. The only thing which will change is the sign. Plus, minus the same term, plus the same term, minus the same term, plus the same term, minus the same term, plus the same term. This is what you get. Alternate plus, minus, plus, minus, plus, minus, plus. This is what you get. And what next? We are supposed to add them together. Let's add them together. What I want to do is, I want to add them together. Right. Adding them together will give me x plus 1 power 6 plus x minus 1 power 6 is equal to, you add these two terms, you get twice of 6c0 x power 6. These terms will get cancelled, right? 6c2 x power 4, okay, you get 2 times 6c2 x power 4. This will get cancelled, plus the next term which you will get is 6c4 2 times, plus this term will get cancelled and what you get is 6c6 over here. This is the expansion for finding this expression. Can we simplify it further? Yes, we can simplify it further. How do we do that? 6C0 is pretty simple. This is 2, which is okay. 6C0 is 1. This is x power 6. What is 6C2? Let's find 6C2 separately. 6C2 is equal to 6 times 5 over 2 times 1, which is 15. Okay, so this is 15 x power 4. What next? 6C4 is same as 6C2. This will again be 15. And you'll have x square. 16C6 is 1. This is what you get. Okay. So the sum of x plus 1 power 6 and x minus 1 power 6 is equal to this. There's another part to this question. What does that part say? That we're supposed to find the value of this expression. So you replace x by root 2 and you get this expression. So let implies this x equal to root 2 implies root 2 plus 1, this root 2 plus 1 power 6 plus root 2 minus 1 power 6 is equal to twice of this expression. What is that? Root 2 power 6. Root 2 power 6 is 2 power 3. 2 power 3, which is 8, plus 15 times root 2 power 4 is 2 power 2, which is 4, plus 15 times square root of 2 whole square, which is 2, plus 1. This is what you get. This 2 is okay. This is 8, which is okay, plus 60 plus 30 plus 1 is what I have. This is 15 times 4 is 60. 15 times 2 is 30. This is what you get. This is 99. 2 times 99 is 198. And yes, that should be my answer for this question. That is my answer for this question over here. This is first part and this is the second part. Right? First we had to find that expression and on the basis of that we could find this. Yes, that's the complete solution for this question. Let's discuss this question next. Show that 9 power n plus 1 minus 8n minus 9 is divisible by 64 whenever n is a positive integer. Positive integer would imply n is a natural number basically. Show that 9 power n plus 1 is divisible by 64. Now what's important over here is this 64 is basically a special number related to, which is related to this 9 power n plus 1 in some way. What's the way in which it is related? That 64 is the square of 8 and yes, this 9 can be written as 8 plus 1. Okay, so we'll begin with this 9 power n plus 1 and try to use binomial expansion on this. Rest other numbers are pretty simple. This is power n plus 1, which is a bit complicated, right? For this will require binomial expansion and for that this should be written in a binomial form, that is 9 can be written as 8 plus 1. The target in such questions is, whenever you encounter such questions, the target is generally to write this 9, this base of 9 as we want to divide with 64, right? 64 is 8 square. So that divisor is important. 9 has to be written as 8 plus 1. In general, whenever you have k power n, k has to be written as something lambda plus or minus 1, where either lambda is the divisor, or 2 lambda, 3 lambda, etc. are divisors, or for that matter lambda square or lambda cube are divisors. What are we saying over here? We are simply saying that in case of 9, we are supposed to write it as 8 plus 1, 9 power n plus 1. In case of k, we can write k as lambda plus or minus 1. In terms of the second term should be 1. Okay, the benefit of this is this particular expression can be written if divisor is this or something of this sort, right? Like we have 8 square, that is 64 over here, right? Okay, that's easy. Yes, that's easy. Let's get rid of this. We don't need this for now. What next? Let's try to solve this question first and see how do we solve this further. So we can write 9 as 8 plus 1. That's the first thing that I observe. 9 can be written as 8 plus 1. So 9 power n plus 1. Let's focus on this. This can be written as 8 plus 1 power n plus 1. And what does that simplify to? So this simplifies to n plus 1 times n plus 1 C0 times 8 power n plus 1. Okay. That's the first thing. Plus n plus 1 C1 times 8 power n. And similarly, you'll have plenty of terms. What about the last few terms? Last few terms, yes. The last term for that matter would be, let's write the last term over here, that will be n plus 1 C n plus 1 times 8 power 0, 1 power n plus 1, which is 1 only. The term before that will be n plus 1 C n, 1 lesser than this, and you'll have 8 power 1, 1 power n, which is 1 only, plus you'll have n plus 1 C n minus 1 times 8 square, yes, plus, will you have something else, right? Let me write one more term. This is n plus 1 C n minus 2 8 power 3, 1 power n minus 2, which is pretty simple, right? Okay. Now in case of divisibility, our target is very simple. In case of divisibility, let me explain one more thing over here. In case of divisibility, one more thing is very important, that if some number n is divisible by k, if some number n is divisible by k, then n can be written as k times some lambda. Lambda is some integer. If n is divisible by k, then n can be represented as k lambda. Now where do you obtain this result from? This result is obtained directly from Euclid's division lemma, which says that if you have a number a, you want to divide by the number b, you'll have some quotient q and some remainder r. If you have any number a, when divided by the number b, you'll get some quotient and you'll get some remainder. A will be equal to this bq plus r. Dividend is equal to divisor into quotient plus remainder. That's what we have. Yes. And if r is 0, then you can say that a is divisible by b. If remainder is 0, then you can say that a is divisible by b. So a can be written as b times some integer over here, b times q, for example. Similarly, for any number n, if it is divisible by k, it can be written as k times lambda, where lambda is some positive integer. Right. So that's the idea that we'll be using over here. Since 9 power n plus 1 is already there, we are supposed to write 9 power n plus 1 minus 8n minus 9, and that could be written as 64k. If it could be written as 64k, then we can say that yes, it is divisible by 64. That's the target. Yes, that's the target. And for that target, we have used one particular expression. That's this. Now, each of these expressions has something special. This is 1, which is very simple. That's not need to worry about that. This is n plus 1 Cn, which is n plus 1 times 8, which is okay. This is 8 square. Observe this expression. This is 8 square, 8 cube and all. From all of these terms, if you want, you can take a 8 square common, because all of these have minimum 8 square in each of these terms, right? So what you can do is you can take 8 square common from here, and what you get is n plus 1 C0 8 power n minus 1, which is an integer, plus similar terms. The last term that you'll have is this n plus 1 Cn minus 1, and this also is an integer, right? So all of these will be positive integers, right? Okay. Plus you have n plus 1 Cn, which is n plus 1 times 8, and plus you have n plus 1 Cn plus 1, which is 1, right? Can we take all of these terms on the LHS? Yes. Okay. So this is equal to 64 times some integer, some positive integer actually. All of these terms are integers, therefore addition will also be some integer. Plus, let's simplify this on the RHS first of all. This is 8n plus 8 plus 1, which is 9. Yes, and now I'll take that on the left hand side, because this is equal to 9 power n plus 1 on the left hand side over here. Since this is the case, this becomes 9 power n plus 1, minus 8n minus 9 on the LHS is equal to 64 times some integer. 64 times some integer. Okay, so that gives me Then 9 power n plus 1 minus 8 and minus 9 is equal to 64 times some integer. What does this give us? This tells us that 9 power n plus 1 minus 8n minus 9 is divisible by 64. Is divisible by 64. And yes, this is what we wanted to prove. This simply implies that this is divisible by 60. A is equal to BQ plus R. If R becomes 0, A is equal to BQ and A is divisible by B. We say that A is divisible by B. But the first step, let's not forget the first step that helped us to actually solve this in this manner using binomial theorem. That's the use of binomial theorem. And this is a complete solution for this question over here. Let's try to solve this question next. Prove that sigma, okay, there's a big sigma, R equal to 0 to n, 3 power R times NCR is equal to 4 power n. How do we go about proving this one? Let's observe. Can we begin with some kind of expression first of all? Yes, maybe. What we can do is, can we write the expansion of 1 plus x power n? Can you help me write the expansion of this? Yes, maybe. This is NC0, 1 power 0 which is 1, 1 power n which is 1 and x power 0 which is 1. NC1 times power of x will increase, power of 1 will reduce, but that will be simply 1. Okay, next term will be NC2 x square. After that you will have NC3 x power 3 plus dot 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 NCn minus 1 times x power n minus 1 is the second last term. The last term will be NCn x power n. Is that okay? Take a look at this expression. And if I want to write it as summation of NCR times x power r, where r goes from 0 to n, is that okay? Let's check this out. This is NC, first term will be NC0 x power 0 which is 1. The next term will be NC1 x power 1, NC2 x power 2, NC3 x power 3 dot 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 up till the last term which is NCn x power n. That's what you will get. Right. So this expansion has been written in a shortcut form in terms of the sigma. I said this. Okay. And can you compare this one with this one over here? Yes, maybe we can, because this is NCR x power r, this is NCR 3 power r. Yes. So with the help of this idea, what I want to write it as, what I want to write is this NCR times 3 power r for r is equal to 0 to n. Therefore, this expression is actually equal to, this expression is actually equal to 1 plus x power n. This is 1 plus something power n. Since you have an NCR, this is 1 plus something. That something is actually 3. This becomes this, and which is equal to 4 power n. Yes, that's the RHS, hence proved. Hence proved. That's a simple proof of this question, as you can see behind me. Is that all? Yes, that's all in this question. And so, with this, we come to the conclusion of this exercise 8.1 from the chapter Binomial Theorem. The NCERT discussion will continue further, and keep watching Vyas Edification videos for further exercises, further solutions, and all the subjects. All the best.